So cognitive science has demonstrated for decades that effective learning isn't a passive process. Learners aren't empty vessels just sitting there waiting to be filled up with new knowledge. Developing learning objects then that requires interaction is a great way to engage students with target content in a much more active way. And there are three foundational categories that I want to discuss right now: navigation interactions, assessment interactions, and element interactions. In this presentation, we're just going to focus on the first two. We're going to save element interactions for a future lesson because they can get much more complex. So let's start with navigation. Most cognitive scientists would agree that for learning to be maximized, prior knowledge usually plays an important role, and this is especially true for navigational interfaces. Having to understand a new and complicated interface can interfere with target content learning. And it's for this reason that instructional multimedia learning objects tend to use fundamental metaphors that are already familiar to students, such as a page that can either be scrolled up and down or flipped back and forth. You might notice in this iBooks example here, digital content has changed dramatically from what we used even just a few years ago. It looks much more impressive from a graphic design perspective, and it's a lot more elegant and much more usable on mobile devices like iPads and Android tablets. Slide-based metaphors are also very common. Perhaps a better name would really be screen, but because presentation software is usually the authoring tool of choice, I guess slide is the term that you typically hear. But the key distinction from pages for slides is that for slide screen, the dimensions are actually fixed. There is no vertical scrolling. And this is typically what we're used to seeing in a slide-based interactive type of presentation. We have content. It occupies a fixed height and a fixed width, typically some text and some graphic elements and perhaps some multimedia built in. This is what we're used to seeing. Now, to be sure, there are other navigational metaphors, and designers often go to great lengths to create visually stunning graphics and environments that reinforce the target content knowledge. But that kind of creativity is just beyond the scope of this course, so we're going to focus on just page and slide metaphors. There are many different frameworks or models for developing navigational interfaces for learning objects, and perhaps the simplest, and we're going to start here, the simplest is linear. You advance forward or backward through some fixed sequence. And typically that means, depending on the device, you're clicking, you're tapping, or some type of gesture, usually a swipe. This would be a typical example that you might see. There are only two directions. You go forward or you go backward. Here's another one. In this case, there's actually some choice. This is actually an assessment question, a formative assessment question, but the progression is still linear. You either go to the next question or go back to the previous question. Contrast those kinds of navigational interfaces with taxonomic models. That's a fancy word, but you can think of these as menus, tables of content, hierarchic or thematic keywords, even procedural tasks and other similar terms. They can be linear, but more often they're designed for non-linear access. The key thing to remember about taxonomic models is that they're designed to simplify or organize the content into easily digested chunks. And these chunks they're like highlight reels, really. And they're designed to establish some type of schema that can help a learner process whatever the new content is. Take a look at a couple examples here. This is probably one that we're very familiar with seeing. Typical slide-based or screen-based content, and it's just a list of links. And they're organized in a way that made sense to the developer in anticipation of it also making sense to the learners. And it doesn't necessarily have to be text-based. Obviously, it can have rich media associated with it. This one in particular I find intriguing. You click on the link, and it then skips forward ahead in time to the appropriate video segment. Very slick, and because the video is actually chroma keyed on top of the black background, it seems very seamless, so to speak. You don't have to go in and out of other screen players. Very slick design. Here's another common setup where you have some menus up at the top. They're text menus, and this is actually a simulation. You can also see the questions here on the left-hand side of the clipboard. This is a very task-oriented type of simulation where you have to make a decision. But the point is, there are navigational options available to you, and they're organized in this, using this medical taxonomy that's appropriate for this particular set of tasks. Here's another example. In this case, we're using kind of a tab-based metaphor, visual metaphor, to arrange the content, and you simply click on a tab to go to that particular part in the presentation. So it's not necessarily linear at all. And here's another common example. We see examples like this in a lot of the new digital content texts where you have some text that describes what the content is, and then you usually have some type of associated graphic, and often in the shape of a button, I guess designed to encourage learners to click on that. But the key point again is that there doesn't necessarily have to be a particular sequence. The learner or the instructor in this case could click on the section that they wanted to. So these are navigational buttons, so to speak. Anyway, so the key takeaway here is that the taxonomy can have any type of, it just has an organizational schema, and that's going to vary depending on what the content is and what the tasks involved will be. Another common model is scenario-based learning. These are highly contextualized scenes that present a problem, a dilemma, or some other kind of meaningful issue. And then they usually challenge the learner to make some type of decision. This model is really common in workplace training and the healthcare industry. For example, in this particular healthcare safety video, you actually have to click on the articles of clothing here or the other tools that are presented in this virtual cabinet, and you have to pick the ones that are most appropriate for the target task here, which is about safety education. So it's decision-based, and that's one of the key takeaways. We see this a lot in public education, especially in language instruction, where you're given particular language-based scenarios. In this Spanish video, for example, each one of these cells here plays back a different scene, and you have to match up the appropriate language to the appropriate scene. And again, the point is the learner has to actually make a decision. In this, this is another healthcare example here. This is kind of a virtual or a simulated diagnosis. We have a sim patient there on the right-hand side, and we have to make a decision about what we do first. And on the left-hand side are the options that are available to us. And again, this is all a very straightforward, simple navigational metaphor here. It's just a slide or a screen-based metaphor, but we actually have to make some type of decision by clicking on something, and then that takes us to another place in the presentation, not necessarily the one in the next linear order. Guided learning is exactly what it sounds like. The use of on-screen elements to scaffold learners to help them understand challenging content. These elements can be text-based, they can be narrated audio, graphic avatars, or even video hosts. Here's some examples. Now, we've all done frog dissection, either physically or virtually, but in a guided navigational model, there's some text in this example here, for example, that tells the learner what it is that they need to do. Contrast that with an avatar-based model. For example, the little cartoon character, our lovely young lady down here in the bottom left-hand corner, is trying to teach us young learners basic sun safety. And so in this particular example, she's actually animated, and there is narration as well. So she speaks to us, she speaks to the learner to tell them what it is that they need to know, and corresponding visuals take place on screen, and then eventually the learner has to click on some of these buttons on the right-hand side to make something happen. We see this a lot, guided learning, in other words, we see this a lot in multimedia learning objects in the corporate workplace. Particularly there, it's interesting, we seem to see a lot of avatar-based instructional learning objects there. And you know what an avatar is, of course. Here's another example. It doesn't necessarily have to be a human avatar. It could be some type of critter, in this case an ant. But the idea here, again, is there's an agent on screen that provides supplemental narration to help the learner do whatever the task is or understand the content. Now, I will say that some of these are poor examples. I've seen many avatar-based guided learning objects that have the agent on screen and the narration text transcribed on screen. And Richard Mayer, of course, would tell us, oh no, that is a terribly bad idea, completely incompatible with what we know about cognitive science. So don't think that just because we see it in professional learning objects that this is actually best practice. Mayer's practices are evidence-based, and those are the ones worth remembering. So don't put narration and transcription, text transcription, on screen at the exact same time. You create a split attention effect. Of course, everybody knows who Bill Nye the Science Guy is. He has an incredible line of science-based digital curricula, and in many of these products, all of which you can pay for online, no surprise there, but in many of these he acts as an on-screen agent. He's chroma keyed out. It's usually on a white background, kind of like what you're looking at here. And then he talks to the learner and guides them through whatever the process is. So that's guided learning. Now let's briefly talk about control. Who controls navigation anyway? Think about this. Is it the instructor or the student? And really, which one is more effective? This is a question that's occupied researchers for a long time, and the verdict is technically still out. We do know that learners don't always make the best choice for a content modality. And typically, they'll try, for example, the path of least resistance. Take this for example. Some populations of learners will choose video over text because they perceive that the act of reading takes less mental invested energy than watching TV or watching a video presentation. But other studies have shown that when modality is held constant, the research suggests a really important finding that's worth remembering. It's very simple. Learners benefit from being able to control the pacing of the digital content. So as developers then, we need to create learning objects that can be flexible, not just for instructor-mediated interactions. It's not just the sage on the stage clicking the buttons for the learners. In many cases, as you well know, especially in blended environments, the students are actually utilizing the digital content independently. And for those types of applications, they are the ones that actually control the pacing, in other words. And so, for example, this could be as simple as rewinding a video playhead or maybe even printing slides before you watch a presentation. The key thing to remember is that iterative learning generally yields better retention. So, as instructional developers then, even if we create a multimedia learning object for live delivery that's mediated by the instructor, we need to think about packaging it as a standalone resource that students can utilize independently also. The other major category of interaction that we often develop for multimedia learning objects is assessment. How do we know that our learners actually learned? Although we have an entire course that focuses on assessment, it's worth mentioning here that the ability to embed digital assessment activities within a learning object, especially for formative assessment, is very, very strategic, largely because the actual grading and delivery of feedback about the success of the targeted task can be automated. The tools for doing this have improved dramatically, and we'll take a look at some of these in a later module. But here are the main categories: multiple choice, fill in the blank, and drag and drop. There are others. Typically, they can be much more sophisticated. But these will be enough for us to be very dangerous and very effective with our students. Of course, learners need to know if they were successful or not, so inserting feedback is obviously essential. There are typically three types of feedback that we see in these digital assessments that are embedded in learning objects. The first is corrective, and it's exactly what it sounds like. Was the response correct, or did they get it wrong? Here's a typical example. There's a task. In this case, they have to click on the correct answer, which is a graphic-based answer, and the feedback then is either an X or a check. And you don't have to have a very sophisticated developmental level to understand that X means wrong and check means right. But sometimes you need more than that, or sometimes as an instructor, you want more feedback. You want it to be a formative opportunity to explain to them why they got it wrong. Here's another example. This, again, still corrective. It's not just a red X this time. We've got some jerk on the left-hand side giving us the thumbs down, basically calling us losers. That's not very nice. And we don't typically see this in learning objects for younger kids for obvious reasons. But you do see this a lot in the training market. And in this case, we even have some other details. We have our scores as well. But all of this is generically called corrective feedback. The opposite of corrective feedback is explanatory feedback. Why was the interaction correct or not? That's the core question that explanatory feedback tries to answer. It's trying to provide the additional details that are needed so that this becomes a remediation experience or an enriching experience for the learner, whether they got it right or wrong. Additional details, relevant details, not extraneous, but relevant details are introduced. For example, in this particular learning object about changing a tire, the learner is challenged to click on the correct response, and of course there is the corrective feedback provided in the form of a green check so that we know we got it right. But down in the bottom right-hand corner, you have additional explanatory feedback. Here's another example, and we see this a lot in science and math. These are called work samples, where after clicking the answer, whether they got it right or wrong, typically additional feedback will come up displaying how that answer was actually calculated. And it can be static or it can be dynamic and narrated even, or it sometimes just has text. But the key takeaway here is that there is additional detail provided to explain to the learner why they got the answer right or why they got it wrong. Finally, let's talk about adaptive feedback. This is way beyond the scope of this course, and it's increasingly sophisticated. It sounds simplistic initially. Adaptive feedback responds to the performance level of the learner. If the performance is X, then we display Y. Ultimately, that's a very simplistic way to look at it. If they get score X, or if they get the task correct, then they go to this page, or they go to this slide, or they go to this screen. But it gets more complicated when we really start using the intelligence that we can build into these algorithms to adapt depending on what the learner does. For example, what happens if they fail the task 3 times in a row? Well, then something else can get displayed. Perhaps it's remediation content. Or what if they get 3 in a row? Maybe the content's too easy for them. Then we skip ahead and we send them somewhere else. So it's this algorithmic type of thinking here that can get very, very complex. And so that's beyond the scope of this course, but you need to know that adaptive feedback is a legitimate and an increasingly popular type of feedback that we tend to see in very sophisticated multimedia learning objects. So that's our introduction to creating interactions inside our learning objects. Again, there are definitely more types of actions, especially those that involve specific elements on screen. But those can be really, really complex, so we'll save them for another module. For right now, what matters is that we understand some of the common navigation and assessment options that are available to us. These are the fundamental building blocks, and I promise we'll add to them later. Thanks for watching.